Okay, so the first one is a video on terminating Ethernet cables, and it is just an RJ45 connector with a Cat5 on a patch cable, and it's just a very basic one. And then I will show you one on doing pass-through cables. Let me know if you guys can or cannot see that. I'm using headphones, so I'm not sure how well this is going to work, so let me know. You guys hear okay? No, okay. Apparently it has to go through the speakers. Let me try that. We'll see how well that does. Now the volume on this is not as loud as the one in my office, so.
In today's video, we're going to talk about how to install a new RJ45 connector on the end of this Cat5 Ethernet patch cable. The tab broke off of this one here, so I've got a new connector we're going to replace it with. As with installing many different types of connectors, it's all about having the right tools. So the first thing we'll do is just cut this end off since we're not going to need it anymore. So you can use anything you want there, a pair of diagonal cutters, or even the printing tool will often come with a set of cutting blades on it as well. So you could have used that. So I like cutting the cable back about 1.5 inches, 1.25 inches to 1.5 inches to get at the wires to prepare them to stick in the connector. Okay, so the tool we'll use to strip the outer jacket off here is the same tool that is used to attach the connector itself. There's a number of different features on here. There's a flat cutter, and there's this cutting feature right here with the slot. And what that allows you to do is put the wire in there and close down on this. And just by rotating the wire around, it just cuts through the outer jacket, and you can easily slide that off. So with that slid off there, we now can separate these wires out. The next step in the process is to basically take the twists out of the wires. You want to kind of get them oriented in about the right way. And I find that it's easy to kind of put the orange and brown on the edges because they're going to be at the edges of the connector we'll look at in a moment. And the blue and green ones are in the middle. So what we'll do is just untwist those. All right, take the twists out of them, and then take those pairs and just kind of run them with your fingers like this to kind of take all the bends out of them, make them nice and straight. And do that for each of the pairs. Okay, all the twists taken out of those wires and the kinks taken out. We're ready to put them in the right order. Now the wires are, again, they're twisted in pairs, and they're color-coded, of course. We've got each pair has got a solid wire, or a wire that is the solid color, and then a wire that has a stripe on it. Sometimes the stripes are across, or sometimes they're a stripe that runs directly along with the wire. And that indicates the pairs. So to put them in the right order, I'll typically keep a little cheat sheet like this around. This is the TIA T-568B wiring order. And this is how I do all my patch cables. There's also an A suffix that's available. And the only difference is that the green pair and the orange pair are swapped. But as long as you make both ends of the wire the same, they'll both work fine. But this is how I've done all my patch cables. So there's an illustration of the connector here. We can see that connector kind of is like that. So in this orientation, this is the way you want the wires to be dressed. So I'll typically do that. And again, this is where keeping the wires long helps. I'll just lay them all out next to each other in that order, keeping the little sheet down here as a guide. So the two orange pairs are first, and then I've got the green stripe that comes across. So I pull that one over here, put that one next to those. And after that, we've got the solid blue and the striped blue. So we'll lay those in there next to them. And then we go with the green solid. So that goes in here next. Let's pull that in and around. And then I have a brown stripe, and brown solid. So that's the order that we want all these wires to be in. So now you just got to kind of play with them a little bit to get them all to lay nice and flush against each other, and keep them all nice and straight. Okay, with them all laying nice and parallel next to each other there. Now we just have to cut them to the length. And there is a guide on the tool to kind of show you that. And I'll just usually eyeball it to make it about a half an inch, just a little bit longer. Right about there should do it just fine. We use the solid cutting blade there to cut through all of these wires simultaneously to make a nice cut that's perpendicular to the wires. Take all those ends off, and now I've got a nice flat end that we use to insert into the connector. Okay, we'll have our last chance here to check the order of the wires and compare them against our template. Everything looks okay. We're ready to install the connector. Tab facing down, we carefully insert the wires into the connector, trying to keep everything nice and flat. Each wire will kind of slide into its own slot. Should go in with very little force. Then I'll turn the connector over and make sure that the wires have reached all the way to the end. And now this is an insulation displacement connector. Each of these little metal tabs here from the contacts, you might be able to see, has a set of pins that kind of pierce through the insulation when the tool is applied here. And that's how the connections are made to the wires. And there's also a little plastic tab that gets pushed down and snaps in place, and that becomes the strain relief that holds it in place. Okay, again, there's no substitute for having the right tool here. We want to insert the connector into the tool. It will bottom out in place. And with that bottomed out in place, the little teeth will grab onto each of those contacts. And as we clamp down on this, it will push those contacts into place. And now this connector is made. The contacts have all been pushed down. The little plastic clip has been pushed here to hold the wire in place, and it's good to go. The last thing we need to do is test it to be sure that all the connections are good, and we put this back in service. So this is the little cable tester that I'll use. Now, you don't have to spend a lot of money on these. This one I picked up for just a few dollars at a Hamfest, but this is a very inexpensive little RJ45 cable tester that can be separated out. We can take this remote unit off to test cables that are at a long distance away. And so I've got one end plugged in here already. This is the end we just finished. So we'll plug that in on this side and turn the connector on. And what it does is it cycles through every one of the pairs or every one of the wires. And we should essentially get a light for every terminal. And if the wires are crossed, then the numbers won't match. Or if a wire isn't connected, the light will be blank. And this also has a slow mode, so you can watch it a little bit more carefully as it goes through each of the 8 wires. So it's as simple as that. We've attached the cable, or we repaired this cable by attaching a new RJ45. And so these tools are a nice little investment to have. The patch cables are pretty expensive when you buy them at the electronics store, but you can make them yourself very inexpensively, and certainly repair them when they get broken. Thanks again for watching.
Okay. Just gonna leave my headset off while we're doing videos here. Any questions about that one? Yeah, it's really easy to make the everything a lot harder. And it depending on what tools you're using and what type of connectors you're using. But I will say the best thing that you can do is have your little diagram out, because the more you do, the easier it gets. But at first, it's really easy to get those little pairs messed up. Okay, now let's see. This one's longer, but it goes into some different tools, and I think it is quite informative.
Welcome to Crosstalk Solutions. My name's Chris, and today we're going to be talking about how to terminate Ethernet cables and the tools that I personally use to terminate either male-ended Ethernet cables.
Sorry, I just saw the would you recommend getting a spool of cable? That's kind of up to you, but I will say that you can buy it online, or my second favorite thing to do is go out and look on like maybe not Craigslist, but some of the different Facebook marketplace in different areas, because a lot of times you'll have jobs where they do like a full cable run and then they have just like a partial spool ready, but they can't use it and they don't, they can't sell it for full price. So see if you can get like a partial spool for just testing and playing with. It's significantly cheaper, and that's one of the things that we did when we were first learning how to do these.
Or female-ended Ethernet cables. Now, to preface all of this, I am not an expert. I do not do this for a living, but I have terminated hundreds of Ethernet cables in my time, so I do have a pretty good feel for what works and what doesn't. And second, there are always 1,000 different ways to do things in IT. If you guys have suggestions for how to improve what I'm showing here today, or perhaps particular tools that you've had a really good experience with, put those down in the comments below, and I would absolutely love to hear that feedback. Okay, so we're going to do some Ethernet termination with both Cat5 and Cat6. There's a little bit of difference between these two, mainly that the Cat6 cable, this is actually Cat6 plenum, and the Cat...
Okay, do you remember us talking about plenum cables? Here he shows you what the different, or what he's talking about with plenum cables.
Cat6 plenum has sort of a plastic separator that runs down in between all of the pairs of cable. But other than that, these are essentially going to be identical. So for terminating male ends, we'll start there because terminating male ends are my least favorite chore. I like the female ends where you can actually punch them down a lot better. But when I do need to terminate male ends, these are what I use. So this is the Easy Cat6 connectors from Platinum Tools, and they go along with this Platinum Tools crimper. And these are a pass-through connector. So essentially, the Ethernet cables get passed.
Be careful with comments like that. So if you'll notice, the cable crimper is significantly different than the ones you guys got in your toolkit. It's just because this one's that's got multiple things in it that we gave, like tools to you guys that do one tool does this, one tool does that, so that you can use individualized tools
through the end, and then you sort of snip them off out of the front. We'll show you that in just a second. But the first thing that we do whenever we're going to be terminating Cat5 or Cat6 cabling is we need to start by exposing the actual wires inside and taking off this jacket. So the way that I do that is with this tool right here. There are a number of similar tools. This one happens to be from Monoprice, but you can actually get similar tools on Amazon or a lot of other places. And I'll have links, by the way, to all of this stuff down in the description below. So the reason that I like this tool is, first of all, you have just a way to just cut cables off right here. But up here in the front, we have an adjustable, so there's a screw here. This allows you to adjust how deep these two channels cut. So depending on the thickness of your cable, essentially you just stick it in here. And you clamp it on where you want, and you basically just twirl it around a couple times and take it off. And then the jacket slides right off, just like that. So it works really, really easily. You can also use a pair of traditional wire strippers to do the same thing, but I just find it so much easier and more accurate to use one of these particularly when I'm stripping, Ethernet, that it's always going to be the same length of cable that I'm stripping. So now this cable here is the Cat6 plenum, and I know that because as soon as I strip away the wires here, we've got two things. We've got this little tiny string that comes in all of these different Ethernet cables. So first thing I do is I clip off that little string. These are a good pair of snips, You can get these at Home Depot or anywhere, but these are invaluable because they can cut through, especially thick cables, just really easily. So we're first just going to cut away this little string right here. There we go. And then we're left with this sort of honking plastic separator that sticks out here. So I just like to cut that off right here at the end. And I sort of bend the cables out of the way like so. And then I get the snips right up as close as I can, just making sure that I'm not actually going to sever any of these cables while I cut. And of course, you know, right now when I'm doing this at my desk, it's not a big deal. But if you only have a certain amount of cable, like if it's already run through the wall and you don't have a lot of slack to spare, you want to make sure you're very, very accurate with how you're cutting these. So the next thing that I do here is I separate out the pairs, and that just basically involves untwisting them. And this is kind of one of the more manual processes, because look, even as I've untwisted this, you can still see there's a lot of sort of twists in the two individual cables themselves. And then you kind of want to just smooth them out with your fingers like so. Now, that's one way of doing it, but recently I bought one of these, and this is the Untwist tool. I don't think this is on Amazon, but I will put a link to this tool down below. So this tool basically is a little channel in the middle that separates out the pairs, so you can very easily untwist. And then additionally, it has all of these channels running down the side that allow you to basically just put a cable in like so, and stretch it out through the channels and straighten it out really, really nicely, right? So let's take a look at the blue pair now. So I just basically separate the tip just a tiny little bit like so, and then this tool goes right on, and you just twist, 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 and pull it back, and it's untwisted the cables now, and then you put cables in the channel and pull. And just that easy, I have very straight, untwisted cables. Let's do these other ones as well. Here's the green one. We're just going to untwist it a little bit. Twist, 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 pull out, straighten. So a few passes straightening, and you can see that this is much, much quicker and more efficient than trying to do all of these with your fingers. And plus, you don't wear out your fingers as much. All right, so the last one here is the brown pair. We're going to open it up, stick this on, twist, twist, pull, and then straighten. All right, there we go. Beautiful. Now I have all of the cables out and straightened, and so it's time to feed them into the male end of the Ethernet connector. We're going to grab one of these. Again, this is the pass-through connector, so the cables are going to go all the way through and then stick out the end, and then this crimp tool will cut off.
Personally, if you get the chance to use the pass-through rather than the ones that they had in the last video, these are a lot easier to use.
The ends as it pushes down and secures the cables. But first, we have to get these cables in the correct order. So just from doing this a lot, I have the order memorized, but you can always just go onto Google and type, Cat 6 wiring diagram, and you'll come up with 100 different pictures that show you exactly how to, exactly the correct order of cables as they need to go into the Ethernet jack. All right, so we're going to do white or.
Okay, the reason you keep seeing the 568B, there is an A and a B, but more frequently you see B used than you do A. So when in doubt, use B unless otherwise told so.
Orange, orange, white, green, then blue. Then we want to do white, blue, then green, then white, brown, then brown. And so what I'm doing here is I'm just kind of getting them generally in order. Now, they're not perfectly straight yet or anything like that, but they're in order. And so I want to hold them real tight, and I kind of just pull them out like this, and then I wave them up and down a little bit. Sometimes I'll go side to side a little bit. What I'm trying to do here is just straighten them out so that they're all right next to each other and in the correct order. Now, if you notice, the ends are all sorts of different lengths. So once I have them straightened out and in the correct order, I kind of put my finger up to the very end, and I just want to do a straight cut with my snips right across the front. And so now I have all of the cables in the correct order, and I've got a flat surface here of across all of the cables. So now we can take our connector and we just sort of slide these right in, and hopefully it'll go through first try. Then you kind of just wiggle them, wiggle them, wiggle them. And as you can see, the cables came right out the front. And then I sort of just squeeze the jacket together, and I get it so the end of the jacket is just sticking into the back end of the Ethernet connector. And there we go. Now, once they're in like this, you want to verify that they went in the correct order, because oftentimes things can change. So white, orange, orange, white, green, blue, green, white, brown, brown. This is the correct order for these cables. Now we can take our Platinum Tools crimper, and we just stick this guy into the crimper, make sure those ends come through. As you can see there, the ends are sticking out over here, and I've got the actual connector, the Cat6 connector right there, and then we just give it a good squeeze. And so not all of the ends fall off. If they didn't all fall off, you can kind of just, play with them a little bit, and they should just pretty much fall right off. And there we go. There we have a nicely done male Ethernet connector. So we have our male connector. We can also do a female connector. And for the
Okay, before he goes on to the female connector, any questions about the RJ5 male connector or the tools used there?
Are the scissors jacketed on one side for any particular reason, or is that just a
I
choice?
think it's just a comfort grip on his. I've seen tin snips used. I've seen it. Basically, you just want something that's really sharp that can cut through thick cable if you're going to be using something like that. I don't personally have, I use wire cutters for mine instead of like snips. So, it's all about, what you want in your own personal kit. So yeah, you can use one like him. You can use wire cutters, whatever you decide to use, whatever is more comfortable for you. Any other questions? Nope. Okay.
female connector, I actually like to use keystone jacks. And the reason I use keystone jacks is because they're very versatile. So with these keystone jacks, we're going to use our punch down tool, and we're going to put the cables into the keystone jacks. Let me hold this up here. So we're going to put the cables into the keystone jack. The ones that I use are these ones from Cable Creation. Product number CL0081 20-pack Cat6 Keystone module. The reason that I like these is because they put the pinout, so the B pinout is right here on the bottom, and you can actually just see exactly where the cables are supposed to go. So it's a nice reference. You never have to look it up if you forget. It's just there's a sticker on here that shows you exactly the right cable pinout. So now we're going to take the other end of our Cat6. We're going to strip it off. Just like that. We're going to snip the little nylon cable or the nylon string. And we're going to separate out our pairs just like we did for the male Ethernet connector. Clip out the plastic separator. And now, just like the male end cable, we need to actually untwist all of these. So we'll use our untwist tool. This untwist tool, by the way, I have an extra one. And so I'm going to be giving away the extra untwist tool on a live stream or something coming up real soon. But I
am not sure if they are passed through or not. I just got them out to look at them today, and it's very difficult for me to tell. Okay, well then they're passed through. There's your question answered. I was going to say I assume they are, but I wasn't sure if they bought the old style so that you guys would know how to use them or not.
We'll also put the link to this untwist tool down in the description below. Okay, and now we have our ends straightened and separated. And now I always start with the orange and green side. So we're going to put these in here like so. And what I do is I put a bend in the little individual wire. And so I put a bend in and I kind of stick it in the right slot. And just with my fingers, I kind of just give it enough pressure so that it sort of sticks into the keystone jack like so. And then we put a little bend into the next one. Make sure that one gets down and sticks. Then we've got the green cables as well. So here we go, green and white green. And then usually once I have one side done, I will punch down this one side. It just makes it easier to stick in there. Now this is a 110 punch tool.
And this is just a different manufacturer, but this is like the punch tools that you guys have.
You can see the blade on the end is the 110 blade. When you're punching down, always double check that the cutting side, so the longer side of the blade, is cutting the right side, right? Because I've done it many times where I accidentally cut the inside, and of course that doesn't do you any good because you just severed your cable. So you want to just always double check that the cutting end of the 110 blade on the punch down tool is on the outside of where you're punching. Okay, so I've got those punched down. These other ends obviously should come right off if they didn't fall off automatically while you were punching them. And now we're going to do the other side here. So we've got our brown, followed by brown white, followed by blue, and then blue white. All right, so those are in. Now we're going to punch down this side. Again, checking where the cutting part of the blade is going. All right, and there we go. And if it doesn't cut perfectly, you can just kind of wiggle it and it'll come right off without too much effort. If you are wiggling it and it's not coming off, that means that it didn't cut really properly. So what you might want to do is just give it another punch down or two, and then you should be good to go. All right, so these keystone jacks come with these little covers to cover everything up nice and neat when you're done punching. These just sort of sit on the top and you can just kind of squeeze them in like so. And now we've got two ends of a cable, one male end, one female end. Now the reason that I like these keystone jacks is because they're very versatile. So you can put these keystone jacks into a 24-port keystone patch panel. You can put these keystone jacks into a wall plate that has like 1, 2, or 4 keystone holes in the wall plate. You can put these keystone jacks into a surface mount box. Again, they're just super, super versatile. So I just always have a ton of these keystone jacks. And then I've got a bunch of options that I can go to in terms of like what I'm actually going to terminate this part into to make a female end connector. Now, when I'm done with everything, let me get rid of some of this trash here. Once I'm done with a cable, so you can see I have a full complete cable here, I test the cable. So I still to this day use the pocket Ethernet, or POC Ethernet, I guess, is.
This one's just a slightly different tool, and I actually went out to look up to see if they still made these, and they do. But because of chip issues and supply chain, they're on like severe back order. So if you're interested in one of these, you know, go look out on eBay and see if you can catch one. The other testers are super cheap, and I think I saw one that was a really decent one for like $10 on Amazon.
How you say it? I never really liked how you say that. Pocket Hernet or POC Ethernet or POC Ethernet. I don't know. I think it should be Pocket Ethernet. It makes more sense to me, but it is what it is. So to test this cable, we're going to plug one end, the male end here, into the POC Ethernet. And then we're going to plug the female end with a little jumper cable into the wire map side of this tester. And by the way, there's all kinds of different testing tools. You can get ones that aren't as fancy as this one that will just basically tell you if you have all of the pairs in the right order. There's also, you know, all the way up to like really nice tools that can test all sorts of different cables, you know, with power over Ethernet and all sorts of good stuff. So this one works in conjunction with my phone. There's an app. So let me turn this guy on. Oh, there we go. We can see the light is on. And so on my app, we're going to hit connect. And that has now connected to the POC Ethernet. I've selected the wire map, and I've selected the TDR, which is going to show me the length of the cable. And we're going to hit measure. And we see 4 pairs straight. And it came back as 3 feet, which I think is like about the minimum that it can do. But if I click on wire map, we can see the pinout, and it gave us the all clear that this cable has tested out successfully. So I thought I had a Cat 5e, but actually both of these are Cat 6 plenum. But if you do.
Okay, questions on that before we go on to the next part, or questions about Ethernet, making Ethernet cables, attaching things like that? We'll go into some more stuff later on when I can actually get in and sit at my desk comfortably without screaming. And then I think that's it for our videos today. Yep. Okay. So next today we have our PowerPoint. And we are going over addressing today. So if there are any questions on this, this is probably one of my least favorite parts to go over. But if I can't answer a question, I will find an answer for you. So bear with me. So there are 4 addressing methods. There's the data link layer MAC address, which is 48-bit, written as 6 pairs of hex numbers, and those are separated by colons. Those are the ones we also call the physical address, and they are embedded within the NICs or the physical NIC cards on there. There's the network layer IP or IP address, which can be used to find any computer in the world, depending on whether they're using a VPN, I suppose. So IPv4 addresses are a 32-bit, and they're written as 4 decimal numbers called octets. IPv6 addresses have 128 bits and are written as 8 blocks of hexadecimal numbers. So there's the transport layer port numbers, which are used to find applications. And then there's application layer FQDNs, computer names and host names. And the FQDNs are those fully qualified domain names. They're just unique character-based names. So traditional MAC addresses contain 2 parts. The first 24 bits are the OUI, or organizationally unique identifier, also called the manufacturer ID. This part is assigned by the IEEE, the IEEE, and that's to keep track of your manufacturer. The second part, the next 24 bits, they make up the extension identifier or the device identification, and each manufacturer assigns their NICs a unique device ID, which in combination is how they find those physical cards. Okay, so this is just a graphic of what a MAC address is. So you got your source and destination MAC. They are a combination of numbers and letters, and as you can see, each section is separated by your colon. Static IP addresses are assigned manually by network administrators. Dynamic IP addresses are automatically assigned by DHCP servers. And apparently we have some more on that in a later chapter. And again, 32-bit IPv4 and 128-bit IPv6. So your 32-bit IPv4 addresses are organized into your 4 groups of 8 or octets. And each of the 4 octets can be anything from 0 to 255. Some IP addresses are reserved. So for example, 772.56.105.12. There's also classful addressing, that's dividing line between the network and host partitions. is determined by the numerical range the IP address falls in. So classful IPv addresses are divided into 5 classes, and it's A, B, C, D, and E. So A, B, and C licensed IP addresses are available for use on the internet. Those are the public IP addresses that we're used to. Companies can use private IP addresses on their private networks. The IANA recommends the following IP addresses be used for private networks, and it just has a range there of the different ones that they suggest using. Classless addressing allows the dividing line between network and host portions to fall anywhere along the string of binary bits in its IP address. And then CIDR, it's also called CIDR notation, or classless interdomain routing, takes the network ID or a host's IP address and follows it with a /, followed by the number of bits that are used for the network ID. NAT, which is frequently used in enterprise environments, or network address translation, is a technique designed to conserve public IP addresses needed by a network. Address translation is a process where a gateway device substitutes the private IP address with its own public address when these computers need access to other networks or to the internet. Port address translation, or PAT, is the process of assigning a TCP port number to each ongoing session between a local host and an internet host. 2 variations to be aware of are SNAT, which is source network address translation. The gateway assigns the same public IP address to a host each time it makes a request to access the internet. And DNAT, or dynamic network address translation, the gateway has a pool of public addresses that it is free to assign to a local host when it makes a request to access the internet. And this is just an example of PAT. There's your internet, and it shows the public IP hitting the gateway and then going back in, or vice versa. IPv6 addresses, this is the 128-bit, as 8 blocks of hexadecimal numbers separated by colons. There's an example down below. Each block is 16 bits. Leading zeros in a 4-character hex blocks can be eliminated. So if a block contains all zeros, they can be written as double colons. Only one set of double colons is to be used in an IP address. Therefore, the above example can be written in 2 ways. So you can take out that first set of zeros and use a double colon, or you can take out one of the other sets of zeros. And the preferred method, because it has that one actually takes out 2, and you can remove more characters and save more time. A link on IPv6 is sometimes called a local link, is any LAN bounded by routers. Neighbors are 2 or more nodes on the same link. Dual stacked is when a network is configured to use IPv6 and IPv4. Tunneling is a method used by IPv6 to transport IPv6 packets through or over an IPv4 network. And then interface ID is the last 64 bits or 4 blocks of an IPv6 address that identifies the interface. Now, the network that I worked on started as an IPv4, then went to dual stacked as the need arose. Dual stacked, usually I see it's usually done when you're converting, like you start as an IPv4, then you need to go to an IPv6. So instead of just flat switching, you'll do the dual stacked and then switch all the way over to an IPv6 sometime in the future. It's just to allow in some cases, I'm sure there are some cases where there are certain types of equipment that don't, if you have like some old legacy equipment, sometimes it doesn't like the newer IPv6 stuff. It just depends, but usually it is, in practice, it's switching from IPv4 to an IPv6, and it's just to give the network admins and everybody else a little bit of time to make sure it's done correctly. At least that's what I've seen. Okay, so types of IPv6 addresses. There's the unicast address, and this specifies a single node on a network. Global address can be routed on the internet. Link local address can be used for communicating with nodes in the same link, or there's the loopback address, and that can be used to test that an interface and supporting protocol stack are functioning properly. Multicast address delivers packets to all the nodes on a network, and an anycast address can identify multiple destinations with packets delivered to the closest destination. So this is just showing, okay, so they all add up to the same amount, but it's just showing how their each section is done a little bit differently. So your global has the 3 bits, then 45, 16, then 64. Then your link address is 64, 64. And then your loopback is 127, and then you have your 1. So that's just the difference in how they are formatted. And this is like when you do your IP config, this is what your IPv6 address looks at like in that. That one's looks like a virtual interface. And then there's one a little bit further down that is for a Wi-Fi interface. So auto configuration with IPv6. IPv6 addressing is designed so that a computer can auto configure its own link local IP address. This is called SLAAC, or stateless address auto configuration. So step 1, the computer creates its address, and it uses that FE80::64 as the first 64 bits, or that's called the prefix. The last 64 bits are generated from the network adapter's MAC address. Step 2, the computer checks to make sure its IP address is unique on the network. And step 3, the computer asks if a router on the network can provide configuration information. This is called a router solicitation message. Okay. Which of the following, now this is an IPv4, not 6, public IP address, A, B, C, D. Okay, I'm getting the same answer from everybody, so let's see. Okay, so D is what they wanted on this one. It's okay, don't feel bad. Like I said, this is my least favorite portion to teach because it's basically just math through IP addresses. So there's where it talks about the different ranges. And those are IP addresses. So that, let's see. And so the 10.0.2.14, that one is listed on the private because it has that one up top here. And then the 172 also listed on the private. And then 192. This is one of those things I don't expect you to remember. I expect that you know where to look it up. And those are private. And then, so the only one that isn't is that 64 down there on the bottom.
So for the 172 address, could you have an example where it's 172.32 and then any number over that, would that be considered a public, or is 31 the cutoff range for the 172?
Because
octet?
any of those can be listed as 255, 32 is not within that range, so it would technically be a public. So yes.
Cool.
So yeah, you're right. They're just certain, yeah, there you go. They're just certain ranges. And that's why I said, unless you're a network administrator who has all this memorized, I don't expect you to remember it, because I don't remember it. I go out and look it up every time I have to. So, I mean, you may have to like put it on a flashcard if there's a test that has it in there, but this is one of those ones that is going to take multiple times to remember. Okay, ports and sockets. So a port, and these ports are a big thing when it comes to ethical hacking, because you're going to see them again and again and again, and knowing what port number goes to what service can help you gather information much more quickly. So a port number is assigned to a process that can receive data. Port numbers ensure data is transmitted to the correct process among multiple processes running on a single device. A socket consists of the host's IP address and the port number of an application running on the host. So colon separates the two values, and the bottom is an example. So there's your IP colon and then the port number right there. So port numbers are divided into three types. There's the well-known 0 to 1023, registered, which are 1024, and then 49151, and then above that are the dynamic and private ports. And here is just a virtual telnet example using port 23 back and forth between your client and server. Domain names and DNS. So character-based names are easier to remember than numeric IP addresses, unless you have an IP address that you constantly use over and over and over again. Generally speaking, you're not going to remember all the IP addresses for the stuff on your servers unless they have a name to them. A URL, or uniform resource locator, is an addressing scheme that identifies where to find a particular resource on a network. The last part of an FQDN is called the top level domain. Domain names must be registered with an internet naming authority that works on behalf of ICANN, and ICANN restricts what types of hosts can be associated with, and those are all your ARPA, MIL, INT, EDU, and Gov. So those can only be, like, EDU can only be schools, Gov can only be government entities. They have to go through, before you buy a domain with that ending, you have to go through a process in order to be used to use those on there. And name resolution is basically the process of discovering an IP address of a host when you already know the name of that host. Okay. DNS is an application layer client server system of computers and databases made up of these elements. So you have your namespace, the entire collection of computer names and their associated IP addresses stored in databases on DNS name servers around the globe. And then you have your name servers, hold databases, which are organized in hierarchical structure. And then you have what are called resolvers, and that's a DNS client that requests information from DNS name servers. Sunny, go lay down. Sorry, my dog's bored, and apparently I am boring. So she was just telling me that. Namespace databases. Each organization that provides host services is responsible for providing and maintaining its own DNS authoritative servers for public access. An authoritative name server is the authority on computer names and their IP addresses for computers in their domains. The domains that the organization is responsible for managing are called a DNS zone. So when you go out and get a cert, oh, sorry. Yeah, she's a senior dog, so her version of huffing is she'll get up, shake her collar, and then kind of go And that's her. I'm throwing a mild tantrum about you making too much noise during my nap. So okay, so that's your namespace databases. And sometimes you have to do name changes and things like that within namespace databases as well. And that's just all the lovely part of keeping up website, any sort of website naming conventions. Name servers. So 4 common types of DNS servers. There's the primary DNS server. This is the authoritative name server for the organization. This holds your authoritative DNS database for your organization zones. Then there's the secondary DNS server, backup authoritative name server for your organization, a caching DNS server, and this accesses the public DNS data and caches the DNS information it collects. A lot of times the caching DNS server is one of the larger targets for what's called DNS cache poisoning. Forwarding DNS server receives queries from local clients, but it doesn't work to resolve the queries. So any of these server types can coexist on the same machine. It just depends on how it's set up in your environment. DNS name servers are organized in a hierarchical structure. At the root level, 13 clusters of root DNS servers hold information used to locate top level or TLD servers. So this is just an example of a hierarchy of name servers. So there's your root server, com.org.edu, and those are the TLD servers. And then you have the authoritative servers underneath them. Does that make sense? Okay. Cool. All right. And this is just a graphic of here's your local DNS name resolver going out to the root name server, and it's going out to the TLD DNS name server, and it finds, okay, there's the .edu, and then it can go out to the rest of it for the authoritative name server. It can do all of this. So it goes, okay, 2, 3, then it goes 4, 5, 6, 7, and then dumps the rest of it out here. So it kind of goes in this little loop to get all of the information. Ways the resolution process can get more complex. A caching server typically is not the same machine as the authoritative server. The caching server exists only to resolve names for its own local clients. Name servers within a company might not have access to root servers. A TLD name server might be aware of an intermediate name server rather than the authoritative name server. Now, there are 2 types of DNS requests. There's recursive lookup and iterative lookup. Recursive is a query that demands a resolution or the answer, nope, can't find it, can't be found. Iterative lookup, this is a query where the local server issues queries to other servers. The other servers only provide information if they have it. It does not technically demand a resolution. These are all types of resource records that are kept in a DNS database. There's the SOA, start of authority, that gives information about the zone. A address record stores name to address mapping for a host. That's usually the one that if you're changing certification to like a different certification authority, that's usually the one that you have to get a new A name record in order to fix. And then there's the quad A or address record that holds the name to address mapping. The IP address is an IPv6 type IP address. Or CNAME, canonical name record, that holds alternative names for your host. PTR or pointer record, this is for verse lookups. There's NS or name server record. This indicates the authoritative name server for a domain. MX, this is your mail exchange record. Identifies a mail server and is used for email traffic. SRV or service record identifies the host name and port of a computer that hosts a specific network service besides email. Text record, which I think we all know TXT and text, and this holds basically any type of freeform text. Again, this is another one that I don't expect you to know everything in it. If you are doing anything with websites, there's a few of these that you can't help but learn as you go along the way. Just be aware there's resource records on a DNS database and that you can look up what they are. DNS server software. Okay, so there's Bind, which is Berkeley Internet Name Domain, and this is the most popular DNS server software. It is open source, which I think most of you know that open source is basically software that the developers have made publicly available. And the reason that open source software is good is that it means that there are people who can look at the codes and go, okay, hey, you know what, you've got a problem here. And whereas closed code are the more for-profit ones, and they are the ones that usually security-wise, if there's a problem, they tend to hide it because it affects their bottom line, where you would think it would be the other way around, but it's actually been proven not to be. Microsoft DNS Server is a built-in DNS service, and that is part of the Windows Server OS. Windows Server is capable of split brain or split horizon development, which is used to handle internal clients and external clients. So this is, if any of you have ever had to go through this, this is troubleshooting addressing problems. This is your event viewer window on Windows. This, if you've ever done any troubleshooting, will quickly become your friend. You can look up different types of things and administrative events, and it should be able to help you pin down different types of things in order to diagnose what's going on. So troubleshooting tools that it's talking about here, you have your command line tools, which are usually a lot of the administrative tools that you're going to be using are command line tools. So just be aware of that. Ping Packet Internet Groper as the utility that you use to verify TCP/IP is installed, bound to the NIC, configured correctly, and communicating with your network. The ping utility sends out a signal called an echo request to another device, and then the other computer responds in the form of an echo reply. And if you get a request timed out, that means something's configured incorrectly, or you're not getting the echo back, which means it's not reachable, or you start troubleshooting from there. ICMP, or Internet Control Message Protocol, is the protocol used by the echo request reply to carry error messages and information about the network. So here's our IPv6 networks use a version of ICMP called version 6, just like version 6 IP. Ping 6 on Linux computers running IPv6. Use ping 6 to verify whether an IPv6 host is available. Ping -6 on Windows computers. Ping, and then you use that -6 switch to verify connectivity on the network. So for ping 6 and ping -6 commands to work over the internet, you have to have access to an IPv6 internet. And you would think that would be, obvious, but sometimes not. The IP config command shows current TCP/IP addressing and domain name informations on a Windows computer. ipconfig/all, which we've talked about a couple times, will bring up your summary of IP addressing information. Here is just that window again, showing the information on it. Use the IP utility to view and manage settings. The IP utility is only available on Unix and Linux systems. Any IP commands that change the state of a link require elevated privileges. This is accomplished by logging in as the root user or by temporarily elevating current user privileges. That's where you use the sudo command if you have not done any Linux. That's what they're talking about there. For Linux, instead of doing IP config, it's IF config, and that does the same thing that we were just talking about with IP config on your Linux or Unix box. So this one looks like they're doing a host name to viewer change the device host name. And then there are different, they call those switches on the end. And those different switches show different information. -I, there's your IP address. And then this one, they're asking for sudo hostname Jill West, and then you have to put in your password, and it's asking you to log in there. Any questions so far? We all doing okay? Good. Okay. Okay, so NS lookup, this is one that you will probably see over and over again. Yeah, it's just a lot of, it's kind of an information dump on this one. So remember this one, NS lookup, this is namespace lookup. This utility allows you to query DNS database from any computer on a network to find the host name of a device by specifying its IP address or vice versa. It's useful to verify information, verifying your host is configured correctly, or troubleshooting your DNS resolution problems. So for reverse DNS lookup, to find the host name of a device whose IP address you know, here is your NS lookup space and then the IP address of your, and that's the command, and then of that IP address is how you would look that up. This utility is available in two modes: interactive, which tests multiple DNS servers at one time, and then non-interactive, in which you test a single server. You can change DNS servers from within interactive mode with the server subcommand and specifying the IP address of the new server. And then in order to get out of interactive mode, you just type exit. The DIG, or Domain Information Groper utility, is available on Linux and Mac OS. This provides more detailed information than NS lookup and uses more reliable sources of information to output its results. Use the DIG to query DNS name servers for information about host addresses and other DNS records. And an IP scanner can be used to gather information about all devices connected to a network. Okay. All right, before we go on to common network issues, are there any questions about the IF/IP config, Linux command line tools, Windows command line tools, any of that? Good so far? Okay. Okay, so incorrect time. To check a domain's computer time source, if you're in a command prompt window, that's the command string for seeing what you're querying, what the source is, basically. And usually if you're in a large network, there is a server that they have specifically that they have tagged as the one that keeps check on the time. DHCP issues, if you're getting DHCP errors, or if multiple clients are having trouble connecting to the network, try check your DHCP server, and then make sure the scope is large enough to account for the number of clients the network must support. Now, the problem usually when you're having, sometimes they'll shortcut on the DHCP, and usually it's better to add like extra space rather than not enough, because otherwise, if you don't have enough numbers for everyone to get on, then it just starts kicking people off. There are, on large networks, they also have the option of doing a shorter lease on the numbers for the IP addresses, in which case you can just, after a certain amount of time of not connecting, it just boots them off that, and then it releases that in order for someone else to be used. Okay, network connection configuration issues, common configuration errors, incorrect IP address, duplicate IP address. Those two were the most common errors that I had when it came to IP and configuration errors. Incorrect subnet mask, gateway, or DNS issues. When a computer is struggling to establish a network connection, always check its IP configuration settings. If the computer is not obtaining an IP address and related information from the server, check to see if your static IP settings are correct. And you can always try switching it over to the dynamic protocol, the DHCP, and see if maybe it was supposed to be set to be dynamic instead of static, and just see what happens. That's just part of troubleshooting. Okay, what protocol does ping use? A, B, C, D. Okay, ICMP, good job. This one is the Internet Control Message Protocol. It's just a lightweight one, and it's used for error messages and information for networks. Okay, so that's it for the PowerPoint. Are there any questions about anything that we've covered tonight? Is there anything that anyone wants to know about network addressing, Ethernet cabling tools, anything like that? Brain is mush, yes. There's only so much of that you can take after a while. Every time I do addressing, my brain feels like that too. Take time. One thing I always tell people is the best thing that you can do after having a whole bunch of information crammed in your brain is get some rest. Because I've had all sorts of problems that I never would have gotten the answer to if I hadn't have taken a break, gone to sleep, come back at it the next day. So go ahead and do what you can, but not to the point where you give yourself a headache. And there is always more research. So if there's anything that you guys want different resources on when you're running into these, or if there's just something that isn't clicking, let me know, and I will see what else I can find to come at it at a different angle. So otherwise, we are good for tonight. I'm going to go ahead and hit stop on the recording.